Good morning, and thank you for joining the Synergis System Design webinar. We'll get kicked off just after the top of the hour this morning. Thank you guys for joining. Good morning, everyone. We'll give everyone some time to get logged in, get settled in, and we'll start probably just after the top of the hour, maybe another 3 to 4 minutes here. So again, sit tight and thanks for joining. Good morning, everyone. Thank you for joining the Synergis System Design webinar this morning. Just after the top of the hour here, we have about 27 attendees in the webinar right now, so let's get started. So my name is Ethan Becker. I'm a channel sales engineer. I cover Central US as my territory. I'm also joined by Howard Rosenthal. He is a channel sales engineer, and he covers Northeast region. Howard's going to be monitoring the question area of the webinar as we go through here today. So if you have any questions as we go through, everyone will be on mute besides Howard and myself. If I go over anything too fast, if there's a lot of questions that come up on a specific area, Howard will interrupt and we can kind of cover it in more detail. But if you do have questions, you can go to the webinar control panel, click the drop down for the question box, enter your question and hit the send to staff. Howard will do his best to answer the questions as we go through the presentation today. Last time I did this, it took about an hour and 20, maybe an hour and a half. So there will be some time at the end if there's additional questions that we can address at the end. So with that, let's get kicked off. So to start with, let's kind of talk about Security Center. So what is Security Center? Well, it's our unified platform that allows us to blend IP video surveillance, access control, and license plate recognition into one intuitive system. It's open architecture, so we give the end user or the SIs the freedom to choose from a large variety of supported hardware. And we're highly scalable. We really can be from one site with a few entities to virtually an unlimited number of sites and entities. I do feel that there's a big misconception out there that Genetec or Security Center is only an enterprise-based solution. I come from the integrator side. I had a lot of success selling to end users in those small entry-level projects, your 10 to 20 readers, 10 to 20 cameras. And based on the licensing packages and some of the appliances that we have that we'll talk about a little bit later this morning, really puts us in a good position for those entry-level entry-level projects that can end up growing and be an enterprise project. So let's dive in a little bit and take a closer look at Security Center. So at the core of Security Center, we have our three core products. So Synergis that we're going to be talking about today for access control, Omnicast for video management, IP video management, and AutoView for license plate recognition. Also part of that core install is going to be some of our optional modules. So maybe if you wanted to do dynamic mapping, video analytics, maybe some communication to intercoms and SIP speakers with Sepelia, web clients, intrusion monitoring, and so on. And then add-on modules through SDKs, long list of add-on modules that we have available. So whether that's building automation, maybe that's destination dispatch with an elevator manufacturer, these could all be add-on modules. What's nice about Security Center is as these add-on modules become more popular, they roll into the core install, making it easier for end users, easier for SIs to install, set up, and deploy Security Center systems. So a little bit more on the open architecture side. So on our camera side, we have a supported device list, which can be found at genetec.com/SDL. That's going to include thousands of different camera models and well over 10 manufacturers. On the access control side that we'll be talking about today, we support Mercury, HID, Axis, Assa Abloy, Allegiant, Salto, just to name a few. On the LPR side, we manufacture high-end LPR cameras, but we also support other cameras and their applications as well. And again, there's an area on our website for more details, and that would be genetec.com/AutoView. For intercoms, really any SIP intercom should work, but not all manufacturers play SIP by the rules. So we do have an area on the supported device list that you could check for intercoms. For intrusion panels, Bosch, DMP, Honeywell, DSC, UTC, just to name a few. And then, like I mentioned earlier, a huge list of technology partners for SDK integrations, whether that's video analytics, video wall, intrusion, building automation, and so on. So let's talk briefly about the system architecture when we're talking about Security Center. So for client applications, there's really 4 client applications that we have. Security Desk is our thick client application. Config Tool is another thick client application, but it's exactly what it sounds like. It's for configuring and setting up the system. Server Admin is used mostly for a licensing tool, but there are some other things that we can do through Server Admin, like backing up and restoring the directory, setting up our SMTP ports and information, and so on. And then our 2 thin client applications would be our mobile and our web client. You're going to get the most functionality of the system through Security Desk, followed by the web client, because through the web client today, we can still do some cardholder configuration and some visitor configuration. And then the mobile, still a very powerful tool with Security Center, but limited on what we can do with card holders and visitors today. So let's talk briefly here about our roles-based architecture and how this makes it easy to deploy, grow, and expand a Security Center system. So with a roles-based architecture, basically a role is a process running on a server. The directory being our main role in the system. So the directory handles our system configuration. It also handles all of our client logins. So anytime we log into Security Center, we are going to be authenticating back to the directory. The way this makes it easy to expand our system is we start with our first server, license it, and install the directory role. And now as the system grows, expands, or possibly we need to add different roles for failover and load balancing, we simply will install Security Center on the next server, license it as an expansion server, point it back to the directory, and now we can add these additional roles to that server, like I said, for expanding the system, for load balancing, or just as the system grows. So a couple slides we'll go through here today, talking about all the different roles we have in the system. So the archiver role, that's the main role for video. It's going to take command and control of our cameras. It's going to handle recording. It's going to handle video indexing and metadata. And if we're doing server-based motion detection, that is the role that will handle that. The access manager is the main role we'll talk about today with Synergis. That's going to take command control of the door controllers, and it's going to log access control events in the database. All of the configuration for the access manager, again, is going to be stored in the directory. The redirector is part of the archiver role, so you won't actually see the redirector in your roles list, but it's going to handle stream redirection, so very important for the archiver role. The map manager will handle any graphical maps we have in the system. LPR manager is going to take command control of the Sharp Vs. It's going to synchronize with patrollers if we have any patrollers in the system, and it's going to store its reads and hits in its SQL database. The media router, that's going to create paths between source and destination for both video and audio streams. The zone manager, if we're doing any software I/O linking. Report manager is the role that's going to handle any automated reports, either emailing or printing based on schedules we set up in the system. The health monitor role is going to raise alerts in the system based on how we set up the health monitor role. Federation role is going to handle any federations of Omnicast or Security Center systems. Intrusion manager is going to manage communication with our intrusion panels. Active Directory role is going to connect to Active Directory and sync users or cardholders if we're using Active Directory. Sepilia role enables SIP-based communication from security desks to clients or intercoms or other SIP-based systems. The web client role is going to enable access to Security Center from a web browser. If we're doing any Kiwi Vision analytics, we will actually have two roles associated with Kiwi Vision. We will have a manager role and an analyzer role. The media gateway really works with both the mobile server and the web server, and that's going to handle redirection of the RTSP streams from Security Center to other roles or external systems. The mobile server role handles mobile access to Security Center, and then our two flavors of SDKs, whether it's a web-based SDK or an application-based SDK. So what roles are required per solution? Well, if we're doing a video-only system, we will need a directory and an archiver. If we're doing an access control, like we'll be talking about today, we'll need a directory and an access manager. If we're doing LPR, we would need directory and an LPR manager, and that full unified solution would consist of a directory, an archiver, an access manager, LPR manager, and any other roles that we needed in the system. So just a quick brief introduction to Security Center, the roles-based architecture. So from here, we'll dive into our main talking point for today, and that's designing access control solutions with Security Center and Synergis. So access control and Synergis basics. So some basic access control terminologies, your request to exit, your door monitoring, maglock, some of the different card technologies out there, whether it's procs, iClass, maybe 13.56 megahertz, the older 125 megahertz. I won't spend a lot of time on this page. The one area I do like to point out though is OSDP. So Open Secure Device Protocol. The majority of all communication from readers going back to the control panels is using a Wiegand technology. Wiegand technology came out in, I believe, 1987. So just imagine we're securing our buildings out there with a technology that's from the 1980s. We really want to be starting to transition customers and users to OSDP, far more secure technology. So just keep that in mind. And if you need additional information on OSDP, feel free to reach out to us and we can definitely provide that for you. So let's talk about access control basics from server to door. So basics, we need a server with the database, a controller, a reader interface board, and then our peripheral devices at the door. Well, how does that look in a Genetec solution? What is that controller? Let's talk a little bit more about what that controller is. Well, Synergis solutions are best designed with the Cloud Link, which is a gateway device. The Cloud Link is really what allows us to have that open architecture when we talk about access control, and allows us to work with all those different manufacturers. Let's talk a little bit more about the Cloud Link. So it's an intelligent and universal appliance providing greater flexibility. Multi-vendor controller, so interface to multiple different modules, multiple different lock support that we'll talk about today. Possible that we might be able to leverage some existing hardware and allow a customer to migrate over to IP-based access control. It has an embedded threat level management and some other security features. PoE enabled, so it will lower your overall installation costs, and it supports OSDP secure channel. So just a little closer look at the Cloud Link, all-in-one appliance. It has embedded 4 RS-45 ports, PoE enabled, but we also have the option to power it with a 9 to 16 volt DC wall wart. And the onboard IOs will be available in the next release of SoftWire. There's also an expansion module for the Cloud Link. So the SYSCLM-308 is an expansion module with 8 additional RS-45 ports, giving us a total of 12 RS-45 ports on the Cloud Link. Typical application for this expansion board would be when we're connecting OSDP readers straight to the Cloud Link. Just an example here of the open architecture. So possibly on the RS-45 port, we could be talking downstream to some HID Vertex modules, the OSDP readers that we just talked about on the last slide, some of the wireless locks that we'll go over today, and then on the IP side, some of the IP and wireless or Wi-Fi locks, our Mercury access door controllers, and if we wanted to do license plate as a credential, we could enroll one of the Sharp V cameras into the Cloud Link. So this is where it can get a little bit confusing. So hopefully not too many questions come up, but if there are, I'm sure Howard will interrupt me and we can talk about it a little bit more. But what is SoftWire? Well, SoftWire is the name of the firmware that runs on the Cloud Link. First version of SoftWire was 10.0. SoftWire is also loaded on as software on our all-in-one appliances. So we have an SV100, an SV300, and an SV350. They can be deployed without the use of a Cloud Link and an access control because they have the SoftWire pre-installed in those appliances. So although we support loading SoftWire on an all-in-one appliance, so the SV100 and 300, or really any computer if you wanted to, it requires an access manager role to be loaded on those machines. It's not really ideal for a multi-site deployment because typically we're not going to require multiple access managers, and we'll talk about the access manager and what its limitations are closer to the end here today. But really, multiple access manager roles in a smaller site or multiple sites is going to make it kind of difficult to program, kind of difficult to manage. So that's one of the reasons why it's not the ideal approach. Also, SoftWire can't be used as part of our Synergis hosted solution. We would have to have a Cloud Link appliance on site. So let's dive in. Let's talk a little bit more about the SV300, which is that all-in-one appliance. So turnkey Genetec appliance, pre-installed with Security Center. Supports access control functionality up to 100 readers. Also has visitor management and import tool included. And we can also add lockdown and Active Directory integration to the SV300 or 100. Again, the 100, slightly less robust as the 300, but is also an option. And that would also include SoftWire. So just an example of how that would look, utilizing an SV300 all-in-one appliance with SoftWire included. Notice we can communicate directly to the access controller here, no need for a Cloud Link. So let's talk about the types of integration we have with hardware. It's really two. So there's a direct integration, so hardware that can talk directly back to the access manager, and integration through SoftWire. Well, what hardware kind of falls in that range? So when we're talking about a direct integration, communication right from the hardware to the access manager role, the Synergis Cloud Link, and the Synergis Master Controller, HID V1000s, HID V2000s and the HID Edge devices can all communicate directly to the Access Manager without the need of a cloud link. Basically, everything else is going to be integrated through software. So our Mercury, our Access, our Asa Abloy, our Solto, our Allegiant, and so on would all need to integrate through software, so a cloud link or an SV300 to communicate back to the Access Manager. So what are our different modes of integration and operation? So we have a supervised mode, a dependent mode, a standalone mode, and a degraded mode. What does that really mean? Well, in a supervised mode, the device is going to operate on its own, and it's going to send events back to Synergis software, and it's going to support overrides. In a dependent mode, the Synergis appliance, so the cloud link, is going to make all of the access control decisions. In a standalone mode, the device operates on its own and buffers events and sends them back to Synergis. And in a degraded mode, when we're talking about a degraded mode, it's usually a device that's disconnected from the cloud link. It's going to grant access to all specific credentials matching a specific facility code. So let's go into some more examples of modes with access control hardware. So when we're talking about supervised mode, what devices fall into there? That's going to be our Asa Abloy locks when they're online. Dependent mode, it's going to be our Mercury panels when they're connected, our access controllers, our Imperial locks, Allegiant when they're connected with Mercury, and so on. And standalone mode is going to be a Mercury panel that's disconnected, our Asa Abloy locks when they're offline, or our access controllers and our Allegiant IP locks as well. So let's dive a little bit more into some architecture here. So basic architecture when we're talking about access control, we have a server with a database talking to an intelligent controller, downstream modules or reader interface boards, readers and inputs, getting us all the way down to our credentials. How does that look in a single site with Genetec? Well, on the top, we have our server running our access manager role. Our intelligent controller would be our cloud link. Could be multiple cloud links, and that's going to be determined on the hardware type that we'll talk about, number of readers, buildings, floors, and so on. And then our downstream modules, readers, and credentials. So in a multi-site architecture, it is recommended by Genetec that we have a cloud link on each site. Nothing's going to stop you from putting one cloud link at our head end site, assuming that we're not exceeding the limitations of the cloud link and bringing all the downstream modules back to the head end site. But what happens if we lose connectivity to site 2? What mode of operation do these downstream modules go into if we lose connection? That's one of the reasons why we recommend a cloud link at each site. So we're talking about designing Synergis solutions. There's some things we need to know. So we need to know how many readers. That's going to help us define our Synergis package. We need to know the hardware they want to use. It's going to help us define our bill of material. And then we need to spec the server and SQL for the server and database. So let's talk a little bit more about the licensing and how we're structured with the licensing. This slide right here is out of the ordering guide. So there's some key points on this slide. So the 3 packages, Enterprise, Pro, and Standard. The main areas we want to pay attention to is one, the number of archivers, or access managers, sorry. So Standard supports 1 access manager, Pro supports 2 access managers, Enterprise is unrestricted. And then the total number of readers. So 64 readers is the maximum for Standard, 256 for Pro, unrestricted for Enterprise. Also the number of clients. So we can have a maximum of 5 clients on a Standard system, a maximum of 10 clients on a Pro system, and we're unrestricted on Enterprise. We're also, anytime we're talking about high availability. So if we want to talk about failover, if we want to talk, we're talking about federation, any of those site licenses, that's going to put us in an Enterprise license package. Some big key areas that are sometimes missed between Standard and Pro, one of them would be threat levels. So we need to be at Pro if we're going to use threat levels. Also Active Directory integration. So if we want to use Active Directory integration, we also need to be on Pro. We talked about the SV300 just a little bit ago. That SV300 and all-in-one licensing kind of falls right in the middle here. Because if you remember, it allows us to have threat levels and Active Directory added on. So it's a nice package that kind of fits right in between our Standard and Pro. So defining Synergis package is really based on our reader count, right? So again, standard up to 64, Pro 256, Enterprise anything over 256. So a basic bill of material or a basic BOM when hardware is not purchased from Genetec. So if you purchase your Mercury or your Access controllers through Genetec, the reader license is going to be included. If we're doing a takeover maybe of a Mercury solution, or you decided to go out and buy your Access controllers from an ADI, then we would have to purchase reader licenses. So we'll go through some basic bill of materials here when the hardware is not purchased through Genetec. First part we're going to have is the GSC-base-5.9 would be the latest version right now. We would have a cloud link more than likely. And then we're going to have the GSC Synergis package based on, whether we're the reader count for one, or maybe some requirements in the system like Active Directory and so on. And then the reader license, we'd also need to add on the reader licenses. So GSC-SY-X, so whatever package, 1R for every reader. So an example, a system with 200 readers on Mercury hardware, not purchased through Genetec. We're at 200 readers, so what is our base package going to be? We're going to be on professional. So our basic bill of material would look something like this. So the packages are also feature dependent, right? Kind of like we talked about with Active Directory and threat levels. So if we had an example, 10 readers, we need failover access manager, failover high availability. We're going to need to be enterprise-based licensing. Example 2, we have 25 readers with Active Directory integration to synchronize card holders. Active Directory needs to be on Pro, even though we're below that 64 readers. So our BOM would look something like this. We would also need to add on the GSC-1AD USCH for the Active Directory integration license. So let's talk about defining the hardware bill of material. Lots of options here, so we'll go through quite a few on these next couple of slides. So designing a Synergis solution is all about working with the access control hardware. Synergis is an open architecture, so the CloudLink controller supports a variety of access control hardware out there, and various factors are going to help us determine the choice of hardware. So maybe the end user has requirements. Maybe it's a takeover and we're trying to reuse some of the hardware. There could be some functionality requirements like lockdown. Other factors could be wiring. Maybe we just want to pull one network drop above the door, so that would help us determine what hardware we're going to use. So just some examples. And again, some of the profile for the supported hardware. So the CloudLink, HID, so either the Vertex or the Edge, the Mercury, ASA Abloy, Allegiant, Salto, Access, and so on. So what controllers connect directly to the access manager? Well, we talked about that a few slides ago. That's going to be the CloudLink, the HID 1000s, HID 2000s, and the Edge Evo devices. So let's take a look at designing with those Vertex, with the Vertex hardware. So this was our first integration when we started with Synergis back in 2007. We have large deployments out there, well over 1,500 readers on some of the deployments, and we offer the most in-depth integration of the HID panels on the market. The controllers are fully autonomous, and when they're offline and disconnected from Synergis, full sync of card holders and credentials, schedules, and access rights. And we also have support for anti-passback, interlock, and lockdown capabilities using the Vertex devices. So we have 2 intelligent controllers that are available for the Vertex. Remember, these can talk directly to the access manager, so there would be no need for a CloudLink or SoftWire in play here. So the first option is the V2000, which is a reader interface network controller. It supports 2 readers. We will sync up to 65,000 card holders and 99,990 offline events. It's really a good board for somewhere where you have maybe a network drop and 2 doors relatively close. The other option for a controller when we're talking about the Vertex is the V1000 network controller. It has no onboard reader ports, but it does support downstream devices, so up to 20 downstream devices via its RS-45 ports, meaning it can do a total of 40 readers with the V100s that we'll talk about on the next slide. It also supports up to 65,000 card holders and 99,990 offline events. So the supported HID Vertex modules, now this gets a little confusing as well here. So these modules, we have two options when we're working with the Vertex modules. These could be downstream from the HID V1000, but we could also go downstream with these modules from a cloud link utilizing the RS-45 ports. So the three flavors of modules: the V100, that's a 2-reader module. The V200 is a 16 input module, and the V3000 is a 12 output module. So talking about connecting those modules directly to the cloud link, what are some design guidelines? Well, they're going to connect the modules via its 4 RS-45 ports to the cloud link. We support 8 HID Vertex modules per port, so a total of 32. And the maximum capacities per cloud link are 64 readers, or 512 inputs, or 384 outputs. And just an overview diagram of how we could use the HID Vertex modules, RS-45 downstream from the cloud link. Again, the other option with those modules would be to use the V1000. No cloud link would be needed. The V1000 again has 2 RS-45 ports, so maximum recommended of HID downstream modules per port is 10, total of 20, or 40 doors max, utilizing the V100s. Again, the V2000 controller, 2-reader, on board, good for locations with Ethernet and 2 doors relatively close. Either case, no cloud link would be required. Both controllers connect straight to the access manager role. So let's dive in. Let's start talking about designing with some Mercury hardware. So with our first version of the Synergis master controller, we only support a direct connection between the master controller and the Mercury MR panels, or the downstream modules, the MR50, 52, 16 in and 16 out. Starting with the new architecture in SoftWire 10.0, we no longer support that direct connection between the cloud link and the Mercury MR panels. All Mercury solutions need to include either an EP or an LP panel with the cloud link. The Synergis Cloud Link and also the Synergis Master Controller will support the intelligent EP-LP panels, the M5 Mercury M5 panels for our Cassie Roscoe takeovers, the MS for the Software House iStar Pro takeovers, and the Honeywell PW6K series and the Pro 3200 series for your WinPack and ProWatch takeovers. This new approach represents an authentic Mercury integration. And just a note on the Pro 3200 series, they require Security Center 5.9 and SoftWire 10.11. So a little while back, Mercury came out with the LP panels. So LP panels are supported in Security Center 5.9 with SoftWire 10.10. If we wanted to enroll an LP panel in an older version of Security Center, it's going to be detected as its EP equivalent. So an LP 1502 would be detected as an EP 1502. Once we get up to the correct version of Security Center, we can quickly upgrade that to an LP panel. And there's more information on Tech Docs if there's any questions on that. So just an overview of the architecture. So whether we're doing the Mercury, LP 1502 or some of the older Mercury, or maybe some of those bridge software, they're all going to reside on the network with the cloud link and communicate RS-45 down to their downstream modules. Let's talk a little bit more about those intelligent controllers. So the LP 2500 has no onboard readers. It has 2 serial ports, supports up to 32 downstream panels, and a total of 64 doors. The LP 1501 is a PoE-enabled controller. It has 2 reader support on it, but 1 door, so in and out. One of the reader ports is used as a serial port, so we can do 8 downstream modules on the 1501 and a maximum of 17 doors. The most popular controller is probably the LP 1502. It has 2 reader support, so 2 doors built in. 1 serial port, again, we can do the 32 downstream modules and a maximum of 64 doors. And then the LP 4502 has 2 reader support for 2 doors, 2 serial ports, again, 32 downstream modules, 64 total doors. This is big in the government with the TLS 1.2, FICAM, and FIPS 2.0 compliancy. So big with PIV readers in government. So then the controllers are going to communicate to our downstream panels, or our MR panels. So a couple flavors. So that MR50 is going to be our single reader panel. MR52 is a dual reader panel. 16 in, 16 input panel, 16 out is a 16 output panel. The MR51E no longer available, but that was a single door, dual reader, in and out, PoE enabled MR panel. The replacement for the MR51 is the MR62E. That's PoE plus, and that only supports OSDP communication to the readers. It's also a 4-door, or 4-reader, 2-door, so in and out on 2 doors, and it requires Security Center 5.9, SoftWire 1011. Again, these are going to connect to the LP panels over RS-45 or IP if we're talking about the MR62E. So some more specifics when we talk about the controllers. So if you're really familiar with Mercury, you probably know that the LP 2500 does support more than 25,000 card holders, or 250,000 card holders, excuse me. This is a limitation of the CloudLink right now. One of our next versions is going to get us up to 500,000 supported card holders on the CloudLink, with our end goal of being able to support 1 million card holders on the CloudLink. So let's talk a little bit about some Mercury design guidelines. Again, the CloudLink is going to connect to the LP panels through IP. The LP panels are going to connect to the downstream modules through RS-45 or IP if we're talking about the MR62E. The maximum capacity per CloudLink is 32 EP LP panels or 256 readers, whatever comes first. And again, we support up to 100 readers on the SV300. In that case, SoftWire is included in the 300, so no CloudLink would be needed. So go into some additional design guidelines. So each Mercury controller supports a defined number of Mercury readers. So if we're talking about the LP1502, we support a maximum of 64 readers on there, back from the slides before. And basically, this is a big, long slide here that says, although we could put, if we put downstream input modules on that 1502, we could have a total of 512 inputs available utilizing that one 1502. But we can only program a maximum of 64 readers per controller. So the way that rule is, so it's going to count for 1 reader if we have 1 reader programmed to a door. It's going to count as 1 reader if we just have a door input programmed as a door. It's going to count as 1 reader if we have just 1 output programmed as a door. It's going to count as 2 of those readers if it's an in and out reader. And it will count as 1 of the readers if it's an elevator reader. So just something to keep in mind. If we wanted to do a whole bunch of inputs and program them as a door, we're still maxed out at 64 doors, regardless of whether it has a reader or not programmed to it. So let's go over some basic bill of materials. I don't go over a lot of these in my design trainings because I think there's a lot that's left out to interpretation by the end user or the SI who's putting the BOM together, but we'll go through a couple here for examples. So we have 3 closets. Closet 1 has 40 readers, 15 inputs, 16 outputs. Closet 2 has 11 readers, 10 inputs, and closet 3 has 50 readers, 10 inputs, 10 outputs. So our basic bill of material could look something like this below here. So we would be at Synergis Pro because we're above 64 readers, below 256. And then the way that and then also we're below, the 32, 256, so a single CloudLink would work for this scenario. So for closet 1 and 3, we put a LP 1502. Closet 2, we put a 1501, and then our total number of MR52s and our 16 ins and 16 outs. The reason I don't like to go over a lot of these, one, I would never probably put a bill of material together with an LP 1501 in a closet. I feel that these are meant to be used as a peripheral device out at the door. And also Murphy's Law is going to tell us that down the road, where are we going to end up adding doors to this site? We're going to end up adding closet 2 where we're restricted to a maximum of 17. The other thing that we could possibly change on this bill of material is we're going to have enough aux inputs and outputs on our 52 boards to probably not need these inputs or output boards. So just an overview on a basic bill of material, but it could be interpreted multiple different ways. Let's talk about the M5 and the MS bridge profile. So if we're replacing a Cassie Roscoe M3000 enclosure, we would utilize the M5 IC, the M5 reader and I/O panels, and the M5 COM board. For replacing the Cassie M2000 enclosures, we would utilize an M5 IC, an M5 2K, and an M5 COM board. And for replacing the software iStar enclosures, we would have the MS ICS, MS ACS, and what other I/O panels that we would need. This is touted as a screwdriver-less replacement. So the Phoenix connectors on all these boards, they're shipped without them. We just pull the Phoenix connectors off of the old Cassie boards, remove them, slide in the new Mercury boards, plug in the Phoenix connectors, and we're good to go. Some cross-referencing for the Cassie Roscoe to the Mercury side. So pretty similar naming convention, should be pretty easy to follow, but the 2RP is now an M5 2RP, the 8RP, M5 8RP, and so on. So some basic architecture when we're talking about taking over a Cassie Roscoe. So what's nice about with the Mercury solution here is they make the M5 COM board. Cassie did have the option to go RS-45 to different enclosures, but it didn't work worth a shit. Utilizing the Mercury and the M5 COM board, we can now consolidate additional enclosures, and there's some more detail on that in the next slide. So again, no need to redesign. We're just replacing the existing Cassie boards with the M5 boards. The total, the maximum total of enclosures per M5 IC is 4, so we can consolidate up to 3 enclosures using the M5 IC and the M5 COM boards. We have a maximum of 2 M5 8RPs per enclosures. We're to follow the same Mercury guidelines that we talked about earlier, so a maximum 64 readers per M5 IC, and up to 256 readers or 32 ICs per CloudLink, whatever comes first. And again, we could utilize the SV300, which supports up to 100 readers with software built in, no need for a CloudLink. So let's talk about designing with Honeywell hardware. Well, Honeywell PW panels are Mercury OEM panels. We have a slide coming up that's going to show us all the supported boards. Some of the boards can't be reused, particularly the older PW5K series boards. They would need to be replaced. And here's kind of a cross-reference. So the PW6K1IC is an IP controller, 2 supervised RS-45 ports, any combination of 32 downstream IOs, and a maximum of 64 doors. So on the downstream panels, we have the PW6K1R2, which is equivalent to an MR52. The PW6K1in is a 16 input panel and would be equivalent to an MR16 in. The PW6K1 out is a 16 output panel, and that'd be equivalent to the MR16 out. Same basic naming conventions when we talk about the PW5K boards down below. And then on the Pro 32 series panels, so the Pro 32 IC, again, it's an IP controller, supports 2 supervised RS-45 ports, any combination of 32 IOs, and can do a maximum of 64 doors. And then our cross-reference for our subpanels down below. So very similar to the PW6K series. So the Pro 32 R2 is equivalent to an MR52. So let's talk about a little bit of architecture here. So what we need to keep in mind if we're doing taking over a ProWatch system utilizing the PW6K IC is that we can natively bring all these boards into Security Center, but the communication between the IC and all of the downstream panels is a proprietary Honeywell communication. So what does that mean? Well, in this chain, if the PW5K1R2, somebody let the smoke out, reaches end of life, we can't simply put in an MR52 in this chain. It would have to be replaced with either a PW5K or a PW6K board. So just what you need, something you need to keep in mind if you run into any of those Honeywell takeovers, you want to reutilize the PW6K, just keep in mind that if the boards die, they need to be replaced with a Honeywell board. So other Mercury OEM hardware. So the LNL or Linnell OnGuard uses LNL boards, which are Mercury OEM. The majority of these boards can be reused in Synergis, no modifications required. So it simplifies takeovers. We really just count the number of readers. we would purchase reader licenses and add a cloud link. So the cross references below here, so the LNL 1300 is the same as an MR50. LNL 1320 is the same as an MR52. 2210 is an LP 1501. 2220 is a 1502. The 3300 is the LP 2500. And the main one that we can't reuse is the LNL 500, which was a small network controller, had no reader ports on it, and it supported, I believe, 16 downstream boards. That would need to be replaced with an EP panel. And then the LNL 1100 is the same as the 16 in. Here's a nice little Mercury conversion table. So what is the part number in Mercury compared to Genetec, RS2, open options, Linnell, and so on. Just the one thing to keep in mind on this sheet is it references some firmware chips to replace some of the older Series 1 Honeywell boards. Those firmware chips are no longer available, so just keep that in mind. So let's talk about designing with access hardware. So Access got into the access control hardware a few years back, and they offer 2 different flavors of boards. So they offer a 1001 and a 1601. They could be connected directly to the SV300 or to the CloudLink. It's going to work independent mode, online mode. So the CloudLink is going to handle all the access control decisions when connected. So our security clearance, anti-passback, interlocks, all that good stuff would be handled by the CloudLink. We support standalone mode when they're offline. And Synergis will sync up to 15,000 offline cardholders to the 1001 or the 1601. Some notes, the 1001 requires PoE, 1601 requires PoE plus. The 1001 also can operate on its own, basically no head-end software like Synergis on top of it, where the 1601 requires, a Genetec to operate. So an overview of architecture, talking about the access controllers. So working with the SV300, so that SV300 supports up to 100 readers. We can support up to 66 access units utilizing the SV300. Again, the access decisions when disconnected are going to be made by the device, and no CloudLink would be required. And if we wanted to use this, the access controllers with a CloudLink, we would support a maximum recommended of access units is 30 per CloudLink. So jumping from the hardware into some electronic locks. So types of electronic locks: intelligent or non-intelligent, online or offline, wireless or wired, or wireless and Wi-Fi. So with an intelligent lock, access control decisions are going to be made by the lock. With an offline lock, it's going to work autonomously with periodic syncs back to the CloudLink. A wired lock is going to utilize PoE or other wired lock, and it's not going to require a battery. And then the other wireless standards utilizing Wi-Fi typically. So where do these locks kind of fall into these categories? So on the intelligent wireless locks, typically going to be Wi-Fi, battery operated. They're going to be offline, so we're going to schedule syncs. Decisions are going to be made locally by the lock, and there's not going to need to be a hub or a router in place with those locks. On the wireless locks, online, non-intelligent, they're going to operate either typically Wi-Fi or 900 megahertz when we're talking about Allegiant. They're going to be battery operated. They're going to be online, always connected. All decisions are going to be made by Synergis CloudLink or the Mercury panels if we're talking about the Allegiant. We're going to have real-time sync with cardholders and events, and there's going to be a hub or a router in the mix. And when we're talking about the PoE locks, they're going to utilize an IP protocol. Power and comms going to come over the IP. They're going to be online, always connected. Decisions are going to be made locally by the lock. We're going to support real-time synchronization of cardholders and events. So let's talk about designing with some of the ASE ABLOY locks. So the Sargent and the Imperial lines of locks. So we'll talk about those here in the next couple slides. So looking at that architecture with ASE ABLOY, so the locks are going to connect through the Synergis CloudLink. We're going to support up to 64 Imperial locks per Synergis CloudLink, so on the Imperial side, and up to 128 IP locks are supported per cloud link. Either case, no dedicated server is going to be required. So talk a little bit more about those Imperial locks. So there's two hubs available with the Imperial. There's the AH40 hub, which is an IP PoE hub, and there's an RS45 AH30 hub. Again, the cloud link handles up to 64 Imperial locks per cloud link. When we're working with the AH30 hubs, the RS45 hubs, they can control up to 8 locks. And each RS45 channel on the cloud link supports up to 8 hubs. We want to try to separate that load evenly with those. The AH40 hub controls up to 16 locks and up to 64 AH40 hubs per cloud link. So we could have a one-to-one ratio, 1 hub to 1 lock. The AH40 requires SoftWire 10.9. So some additional specifics when we're talking about the Imperial line. So again, the communication cloud link to hub is either going to be RS45 if we're doing the AH30 or IP if we're doing the AH40. The distance from hub to lock is about 50 feet. Scalability, so 64 locks per cloud link, 8 locks per Imperial hub, up to 8 hubs per RS45 cloud link, but the recommended is to keep that closer to 2 hubs per cloud link, so published numbers compared to your design numbers. And up to 16 locks per IP hub, and again, up to 64 IP hubs on that 1-to-1 ratio. Standard reader support, so your MyFair, DesFire, HID iClass, HID Prox. And the operation is going to be online, non-intelligent, so the cloud link is going to control access, and the Imperial is going to report events back to the cloud link. So let's look at the differences here between the Imperial and the Sergeant line of locks. So on the Imperial side, we're utilizing both RS45 and IP communication. The lock's going to communicate to the cloud link via its hub. It's going to be online, so it supports frequent changes to access rights, and they offer solutions for cabinet locks, server cabinets, and glass readers. On the Sergeant side, that's going to utilize IT infrastructure, so Wi-Fi. It's going to communicate directly to the cloud link, no hub or router in the mix. It's going to be offline, so infrequent changes to access rights, and it's limited to door locks. So from there, let's jump in. Let's talk a little bit about Salto. They have 2 options available. So the Salto Salus overview. So Salus is a wireless lock technology, only supports Salus-enabled locks. They're online locks, so a door controller or intelligent device manages control of the locks, like the cloud link. Online locks offer real-time connectivity and reporting, as well as greater control, and they offer locks for doors, cabinets, server locks. There's some padlocks also available, so a lot of different options with the Salus line. The architecture, when we're talking about Salus, we're going to have a router in the mix. So we have 2 flavors of routers that we can use. We could use an IP router, which will support up to 64 locks, or an RS45 router that's going to support up to 16 locks. From the router, it's going to be RS45 down to nodes, and then the nodes will communicate to the locks, regardless if we're using the IP or the RS45 router. Again, must be Salus-enabled locks. So let's go talk a little bit more in depth about that. So the locks connect through the Salus routers to the Synergis cloud link, either through that RS45 or PoE. Up to 64 locks per Synergis cloud link. Each RS45 router supports 16 locks across multiple nodes, and we can have 1 router at each one of our RS45 ports on the cloud link, so a total of 4 times 16. 1 or more PoE routers can be connected to the same cloud link, but we can't exceed that 64, that max of 64. So some additional information when we're talking about the Salus line. So our communication, again, it's going to be either RS45 or IP communication from the router to the cloud link. Some distances to keep in mind. So our distance from node to lock is roughly 32 feet. From the cloud link to the router utilizing RS45 is 2,000 feet. Our router to node, 150, and node to node, roughly 80 feet. Scalability, got a maximum of 64 locks per cloud link, 64 locks per IP router, and 16 locks per RS45 router. Supported readers are your MyFair, your DesFire, your HID, iClass, and Prox. Operation is going to be online, non-intelligent, so Synergis CloudLink is going to control the access, and Salus is going to report events back to the CloudLink. Again, supported locks, we want to make sure that they're the Salus-enabled locks. So the other technology that Salto offers is the SVN technology. So SVN uses data on card technology. This technology is meant to enable access control on mechanical doors without wiring. So we would just replace the old locks with the Salto SVN locks, and we're going to utilize data on card for access control information. So access rules, lost card, battery levels, etc. is going to be propagated by the card holders as they badge through the system. The SVN is a plugin based integration. So we communicate through the plugin with the Salto virtual network offline and online devices. This is a software to software integration. So even if the hardware for this is purchased through Genetec, we're still going to require a license for the plugin and a license per lock. The Salto plugin 3.0 requires Security Center 5.6, SR1, CU1, or later. And just an overview on the SVN. So we would have the virtual network running on the Salto server. We have Security Center and the Access Manager running on our server, utilizing the plugin to communicate back and forth. We would have refresh readers in place in the SVN. So a refresh reader would be a reader that we know the card holders are going to hit on a daily basis. This is going to download and upload all the information from the card since the last time it hit a refresh. And then as they go around the building, swiping at their offline readers, we can upload different access levels to them, pull battery information, and so on until we reach back to the refresh reader and download that to the Salto virtual network and through the plugin back to Security Center. So let's talk about designing with Allegiant hardware and wireless locks. So there's two integrations available for the Allegiant locks. There's a Mercury integration. So in this integration, the Allegiant AD, LE, and NDE series locks, they're going to require a Mercury EP or LP panel or a Honeywell panel. The AD series locks require Security Center 5.5 and SoftWire 10.2. And the NDE and LE locks are going to require Security Center 5.7, SoftWire 10.6. There's also the Engage IP integration. So in this integration, the intelligent LE, NDE, and control locks communicate directly to the CloudLink via the Engage gateway. And the Engage integration requires Security Center 5.8, SoftWire 10.10. So let's talk a little bit more about the Mercury integration. So if we're using the Mercury integration with the Allegiant locks, the locks are going to communicate with the Mercury EP, LP through its RS-45 ports to either an AD300, which is a radio, or an AD400. As of SoftWire, as of Security Center 5.9 and SoftWire 10.11, all EP or LP panels can be used when we're talking about the Allegiant. Prior versions, we only the LP 1501 and the EP 2500 were supported. The AD400 requires a PIM 400 communication module, and that utilizes a 900 megahertz channel, which allows us for longer range. So up to 1,000 feet clear line of sight, up to 200 feet when we're trying to transmit through walls and so on. The LE and ND locks connect to the Engage gateway over Bluetooth, so a much shorter range when we're talking about that integration. And the same supported readers, so MyFair, DesFire, HID Prox. This is an intelligent locks this integration, the locks are non-intelligent. I apologize. So the CloudLink or the EP panels are going to control the access. So some more design guidelines when we're talking about the Mercury integration. So same requirements that we talked about earlier with the CloudLink. So 32 LP panels or 256 locks, whatever comes first. The EP panels are going to connect over RS-45 to either the AD300, the PIM 400, or the Engage gateway. We can have up to 8 PIM 400s per RS-45 on the LP 1501 and up to 16 on the LP panels that have 2 RS-45. We can do up to 16 AD 400s per PIM and up to 10 NDE locks per gateway. And just an overview here of how that integration would look with Mercury. So if we're using, the 2500 controller up here, RS45 to the AD300 series locks, we can support up to 16. If we're using the PIM 400, 900 megahertz to the AD400 locks, we support up to 16 as well. And using the Engage gateway, up to 16 gateways, up to 64 locks, and that would be for the LE series or the NDE series locks. So Allegiant with the Engage IP integration. So using the direct Engage IP integration, the intelligent LE, NDE, and control locks communicate to the cloud link through that gateway, and the locks connect to the gateway over Bluetooth, so a much shorter range from the gateway to lock. This integration, again, requires Security Center 5.8, software 10.10. The NDE and LE locks support 5,000 credentials. Some of the smaller control locks will only support 200 credentials. The control locks also don't support any unlock schedules. And the access control decisions are made by the lock, so they're running in a standalone mode with periodic syncs back to the cloud link. Just some additional information. So again, this integration requires Security Center 5.8, software 10.10, up to 10 locks per gateway, and the cloud link supports up to 32 gateways or 200 locks, whatever comes first. And here we'll have a nice little overview. So IP gateway, maximum 32 per cloud link, maximum 10 per gateway, Bluetooth communication from the gateway to the locks. So we also have the ability to assign a license plate as a credential. And if we wanted to do that, we would have to use one of our Sharp V cameras. And very easy integration. So we're going to deploy the Sharp V. Typically, we see this for gates. So we would deploy this out at the gate. We would be able then to enter the license plate as a credential underneath the card holder. As they approach the gate, we could use the onboard outputs, IOs on the Sharp to trigger the gate. So really nice, quick one slide here, but very useful, very nice, especially for gates. Nobody wants to get out or have those big giant maxi prox readers. So a different option for that. So we know Genetec is now a life safety power. We know we sell life safety power. Prior to this, we were already providing, we had two flavors of enclosures, a small and a large enclosure, and they already had life safety power supplies on them. So now we've kind of expanded to that line, and now we're able to resell life safety power enclosures. So we'll go over those a little bit here. So Life Safety Power offers enclosures that support hardware from Mercury or HID, large variety of size options, wiring options, mounting a device. We could also have a rack mount option, and they're going to come with power supplies, either a standard power supply or a network managed power supply. So just going over the part number here, so you get a bill of material back from Genetec with this big long part number for your enclosures. How does this really break down? Well, the first part is going to indicate what's the total number of watts available in the system. It's also going to start with FPO unless it's a rack mount version. If it's a rack mount version, the part number would start with RG. Part two of the part number, we want to pay attention to this M8 and what's after the M8. So if we see an NL4 or NL2, that's going to indicate that the power supply is network managed. The next area is going to give us the enclosure size, which we'll go over on the next part, or next slide, excuse me. Number 4 indicates what's our wire management. So P for Panduit, T for tie wrap. Next area is going to indicate the total number of doors that can be wired to the enclosure. So this one's good for 16 doors. And then the last section is it pre-wired or not? So if we see an A at the end, it's going to indicate that this enclosure is pre-wired for Mercury, LP1502s, and MR52s. So diving into that naming, the E1, E2, E8, the higher the number is going to indicate the larger the enclosure is. The M or the V, that's going to let us know whether it's Mercury backplane or a Vertex backplane. The number after that is going to indicate, so if we see a 1 after that, that's going to indicate that we have a backplane on the door to mount modules on the door. And just a note, All of the access control hardware for Mercury or HID is not included in these enclosures. It's just going to be the power supplies. So again, another examples of the power supplies. So an E4M for Mercury, 4 boards, 8 readers. The E8M1, so now we have the backplane on the door. We could do up to 16. And the same for the Vertex side. Here's just an overview of the wire management. So Panduit obviously gives you a little bit cleaner install, looks a little bit nicer, but it's a little bit more expensive compared to the tie wrap option. If we wanted to mount the CloudLink inside one of the life safety power enclosures, we would need to include the mounting plate. So the EPLT-1M is the mounting plate that will fit inside the life safety enclosures and allow us to mount a CloudLink, but also allow us to mount some of those smaller Mercury boards, so the LP1501, the MR50, or the MR62E. So here's the replacement part numbers for the old small and large enclosures. So on the small enclosure side, if we're doing Mercury, SYS, FPO75, D8PE2M/P, if we wanted Panduit, and that's going to be good for 2 Mercury modules and 1 CloudLink. On the large enclosure side, large enclosure is going to be good for 4 Mercury modules and 1 CloudLink. Either one's going to be 6 amp power supply included. Let's talk about creating some bill of materials with Synergis solutions. What do we need to know to build that Synergis bomb? Well, we really need the takeoffs. We need to know number of IDFs, MDFs, reader counts per MDF, IDF, IO counts, elevators, etc. What other information that we want to know? Is it going to be a takeoff? If there's no takeoff, is it a fresh install or takeover? What's the preferred hardware? Are we using HID, Mercury, maybe some electronic locks? If we can't provide a takeoff, then we're going to need to know the number of controllers, number of readers, additional inputs per controller. If there's elevators involved, we need to know the total number of cabs and the number of floors, and also what IDF or MDF the elevator is going to be wired back to. And then do we want to include enclosures? Do we need a server included? Maybe readers, cards, printers, enrollment readers, and so on. So just a real quick example, bill of material example, Mercury solution using life safety enclosures. So the request would come in maybe something like this. So it's a fresh install using Mercury. We have 2 controllers or IDFs, total number of readers per IDF. So IDF1 has 9, IDF2 has 20, and then the additional inputs and outputs, no elevators, no readers when we want life safety pre-wired. And an example of what a bill of material could come back like. So again, I would probably never put an LP1501 in an IDF here, but you could. And then some examples for life safety enclosures. And keep in mind, we could also use the SV300 in this scenario, and no CloudLink would be needed. Let's talk about elevator design a little bit. So main information we need to collect if there's elevator control for a project would be the number of elevator cabs, the number of floors per cab, which controller or IDF the cabs are going to be wired back to, and whether or not floor tracking is required. So based on that information we've gathered above, we'll know that each elevator cab requires a reader. Each button inside the cab requires an output that would be activated based on their card holder permissions. If we're doing floor tracking, then we would need inputs to detect which floor button is pressed. So we would need 1 input per floor button. And for high-rise buildings, we want to pay attention to the Wiegand wiring limitation. So we're going with OSDP, so we don't have to worry about that as much, but 500 feet or roughly 40 floors is about the limitation for Wiegand. So some additional elevator design guidelines. So if we're going with a CloudLink and we're using Mercury Vertex devices downstream from the CloudLink, some rules that we need to keep in mind. We can use the CloudLink to control elevators and doors. We're going to use the same access control rules for hardware we talked about earlier, so a maximum of 64 readers using the HID V100 modules. And if we're designing with Mercury and a CloudLink, we can use the same. We're going to use the same guidelines from before, so total of 32 LPs or 256 readers, whatever comes first. The EP or LP panel can be used for doors and elevators at the same time. We support elevator control offline, so when the LP panel is not connected to the CloudLink, but there's some rules that apply there. So output relays from different boards must be assigned in consecutive blocks, meaning output from last output on board A must be followed by the first output on board B, and floor tracking would not be supported in offline mode. If we decided to go with the HID V1000 controllers downstream to the HID V100s, we would need to dedicate that V1000 controller to the elevator. Can't do doors, can't do multiple elevators on it, so just something to keep in mind. So what if it isn't a fresh new install? For takeovers, we would check the compatibility of the existing hardware. We would create a bill of material consisting of replacing hardware with its equivalent, add in a CloudLink, and if the hardware is reusable, we would just include the reader licenses and add the CloudLink as needed. But a couple different options when it comes to importing existing card holders into Synergis. So preferred method is to do an Active Directory, but we could also utilize our import tool, which is going to allow us to sync card holder data in a CSV format up to 5,000 lines. We could utilize our card synchronization plugin. So that would import and sync card holders from maybe an Azure Active Directory, maybe from other databases or text files. And then we also offer a database conversion. So we could import, utilizing professional services, we could do an import for cardholder data, access rules, and some other data that we'll talk about on the next slide. So working with those solutions, the M5, the MS Bridge, or Honeywell takeovers, Linnell takeovers, that might require a database migration, right? So it's offered by Genetec's professional services team. The majority of access control manufacturers are going to use a SQL database. Some examples, so Linnell, GE, Cassie Roscoe, the AMEG, Honeywell, they all use a SQL database, making it a lot easier for our professional services to convert. The data types that are typically converted would be your cardholder profiles, cardholder groups, credentials, some custom fields, access rules, access schedules, door entities, and so on and so forth. We have a flow chart I'll show on the next slide that kind of helps you determine what's the right way to go for converting that existing database, whether it's using the import tool, Active Directory, or filling out the database migration form and sending that back to channel sales. So again, just a nice little flow chart. We can walk our way through and see what is the best way to convert an existing system over. And if we needed to do professional services, we would want to work with channel sales, fill out the migration form, send it back in for an accurate quote. Here's just an example of some of the systems that we have experience with and what you can kind of expect out of them. This is by no means all of the systems we've converted, but just an example. So when we're talking about designing the Access Manager server design, so an Access Manager following the recommended server specs, which can be found in the system requirement docs on Tech Docs. So if we have a standalone system running a directory and an Access Manager, access control only, all on one server, we support 1,024 readers through the CloudLink and 25,000 card holders per Access Manager. If we were doing a standalone Access Manager, so a server just running the Access Manager role, 2,048 readers utilizing the CloudLink, and still 25,000 card holders. And if we were doing that one unified solution that we talked about earlier on, so a directory, an archiver, and an Access Manager all residing on the same server, we can do 100 cameras, 200 megabytes per second, and 200 readers. We're also only going to sync 40,000 card holders. So one thing to keep in mind when we're talking about sizing the SQL when it comes to the Access Manager is all that the Access Manager is storing is events. All of the configuration is all going to be stored in the Directory Manager. Card holders, access rules, schedules, etc. So Access Manager scalability. So we start out with a system. We have a directory and an Access Manager residing on one server. Again, that's going to give us a maximum of 1,024 readers. If we need to grow beyond that, we would just install an expansion server, give it another access manager role, and now this one could do 2048 readers. So just a real quick overview on how we can expand and grow. So some additional access manager design guidelines. Again, going back to what we talked about with the CloudLink and SoftWire, in a multi-site environment, there's no need for an access manager at each site. A single access manager at the main site with the CloudLink units at each remote site is the preferred design. It's also the default design if we're doing a Synergis hosted solution where the access manager is hosted in the cloud and the cloud links are deployed at each site. And again, in a multi-site environment with Mercury, EP, LP panels, it is recommended to have a cloud link at each site. Deploying the LP panels at each site and controlling them using one cloud link from a single location across a LAN may work, but it's not recommended. And again, it goes to what mode do those panels go into if they lose communication from the cloud link. Let's talk about access manager failover design. So failover, high availability, like we talked about with the licensing, it's going to be available in enterprise only, and there's no added part number for failover of the access manager. It is included in the Synergis enterprise package. Both main access manager server and its failover are going to need to point to an external SQL instance. For high availability, a shared SQL could be redundant with always on instance. So we have a scenario failover solution that requires one single access manager. What's the total number of servers we would need? Well, we're going to need 3 servers. So we would need a server number 1 for the main access manager, server number 2 for the failover access manager, and server number 3 for SQL. Failover solution for 2 access managers. How many servers will we need? Well, it's going to kind of depend, and we'll go through this quickly. We would need at least 5. So access manager 1, access manager 2, failover 1, failover 2. If the external SQL server is accessible by all the access managers and the failover managers, then one SQL server would suffice here. So we would end up with the 5 servers, but if they weren't able to all connect to them, we could have an additional server. So we would maybe have 6 servers. So one SQL server for access manager 1, failover 1, one SQL server for access manager 2, failover 2. It's not recommended to use an end-to-one failover, multiple access manager servers failing to the same failover server. If you do, if not, we need to make sure there's a couple things in place. So the destination server, we want to make sure that it can handle the load. We want to make sure that there's no HID vertex as part of the design. Each access manager role needs to have the Synergis extension with a different discovery port. And we also could use a Windows or NEC clustering are also supported for high availability options with the access manager. So just some final notes to go over here quickly. So Resource Hub, so resources.genetec.com, great place to find all the marketing material, a lot of good information there. For all the technical information, we'd want to visit techdocs.genetec.com. Really has everything, all of our technical information is available there. We also have a couple YouTube channels, so Genetec Training and just the regular Genetec, a lot of good videos out there. If you do browse through those, just pay attention to the date when they were published. There are some older videos out there. And then for some pre-sales support, so anytime we're working on pre-sales, bill of materials, we want to send that to either your RSM or your channel sales. Anytime we want to get verification on a design, that would go to typically your sales engineer, or you could send that to sales engineering at Genetec or inside sales engineering at Genetec. Any questions on purchase orders or any of that would go to customer service at Genetec. Again, I thank everyone for joining us today. I hope you found this beneficial, got some good information out of it, and I'll open it up and see if Howard has any questions we need to go over.
I don't think we do, Ethan. There were several questions during the training, but I think I've covered them all for now.
Perfect, I appreciate that. Well, Howard and I will stay on for the next few minutes. If you guys do have any questions, feel free to type them in the questions box and we'll get to answering them. Thanks again, everyone. We're not getting too much for questions anymore, so I think I'll end the webinar here. Again, thank you everyone for joining. Thank you, Howard, for managing the questions, and I'll touch base with you, Howard, in a few minutes just for some feedback. Thanks again, everyone.
Sounds good. Thanks, Ethan.
Thank you.